Hello and welcome to lesson number 2 in Unit 6 Exponent Laws in our Grade 11 University College math class. Today's lesson is powers with integer exponents, so that would be 0 or negative. We're very used to seeing positive exponents when we're working with powers. Today we're going to explore 0 and negative exponents. So we're going to start with 0 exponents. Now normally this first part is something that I would walk you guys, the students, through in class. As sort of a proof of concept as to why something to the exponent or anything to the exponent 0 is equal to 1. So I'll just take you through it. It's already filled in, so maybe pause the video and fill this in, and then I can sort of talk you through it. So pause, copy, come on back, and I'll talk. Okay, you're back. Here's the scoop. So as a proof of concept, the first thing we've been asked to do is use the exponent law to subtract the exponents. That's what we did first. So we have 5 to the exponent 4 divided by 5 to the exponent 4. That should be 5 to the exponent 4 minus 4, which gives us 5 to the exponent 0. So we have the introduction of a 0 exponent here. The next thing we want to do is expand the powers and then reduce the expression. So 5 to the exponent 4 over 5 to the exponent 4 is 5 times 5 times 5 times 5 over 5 times 5 times 5 times 5. And again, what's nice is that when we're dividing the numerator and the denominator by the same number, we can get an equivalent fraction, which we've done 4 times here. We've divided both numerator and denominator by 5 4 times. We've effectively reduced this thing down to 1 times 1 times 1 times 1 over 1 times 1 times 1 times 1, which gives us 1. And so when we type this into our calculator, 5 to the exponent 4 divided by 5 to the exponent 4, we get 1 is our answer. And here's the reason why. You can see it right here. Is that whenever you have anything to the exponent 0, think of it as having the same amount of stuff, whether it's coefficients or variables or whatever, in the numerator and the denominator, and they effectively cancel each other out 100%. And we're left with a ones or a bunch of ones over 1 or a bunch of ones. So that's why anything to the exponent 0 is equal to 1. Now, if this explanation, if you don't particularly care for it, that's okay. It's really just super important that you remember that any base to the exponent 0 is going to be equal to 1. And that's what we have right here. Now, this little part we also have a little bit of fun talking about in class, where we say that the base can't equal 0. There's a lot of debate in math circles about what 0 to the exponent 0 is. We don't have to spend our time or our mental energy on that, but it is something that if you are heading into the field of mathematics, it is still one of those ongoing debates. So if you thought everything in math was already figured out, think again. Still some debate out there in the math fields. Okay, let's do a few examples. It's going to be very straightforward because, as you can imagine, every single one of these is going to equal 1 when we both simplify and then evaluate. So that's our instruction here. We have evaluate, but first we're going to simplify, which again means bringing it to a single power with a positive exponent. So one instance where you might find a base to the exponent 0 is multiplying 2 powers with the same base but with opposite exponents. So in this case we have 3 and negative 3 being multiplied, which means that we add them. 3 plus negative 3 gives you 5 to the exponent 0. So they're simplified. And then when we're asked to evaluate it, we get 1, as you can imagine. A second time that might show up is 2 identical powers that are being divided. So again, identical power being divided, we subtract our exponents. So here we have, I'm cheating a little bit, there's our simplified answer, 4 to the exponent 0, and then 1 would be our evaluated answer. A third instance is a power of a power, where one of the 2 numbers is a 0. So in this case we have 2 cubed, whole thing to the exponent 0. So there's our 0. Power of a power means we're going to be multiplying these, and as you know, anything times 0 is going to give you 0. So 2 to the exponent 0 is our simplified answer, followed by our evaluated answer of 1. So those are 3 instances. Now we're going to work 3 more together. So let's jump back over to D. This is another power of a power. It just so happens though that this time our exponent is on the inside of the pair of exponents you get in a power of a power. So we would have, in this case, 1/3 to the exponent 0 times 3, which gives you 1/3 to the exponent 0. So that is our simplified answer, and then we evaluate. Anything to the exponent 0 is going to give us 1. So there we go. That's our evaluated answer. Here was our simplified answer. Hopefully the color helps you. I think it does help some people for sure. Okay, and a second example. Now we've got just a few more steps, but the same idea. So in our numerator, we have a power, so 2 to the exponent 3 to the exponent 5 is going to give us 2 to the exponent 3 times 5, or 15, divided by 2 to the exponent 5 times 3, or 2 to the exponent 15 as well. So we have two identical powers being divided. That's going to give us 2 to the exponent 15 minus 15, or 2 to the exponent 0. That is now simplified, and we go on to evaluate, which gives us 1. Getting pretty repetitive about now. One more example to go, thankfully. So same idea as before. Our numerator is going to stay the same. We have negative 3 to the exponent 8, and that's going to be over. So same base being multiplied, we are going to add these exponents together. So that's going to be negative 3 to the exponent 5 plus 3, or 8. And now dividing, identical powers. We keep the base, subtract the exponents. That's going to give us negative 3 to the exponent 0. You'll notice I continue to bracket the negative 3 in its entirety. It doesn't really matter up until this last evaluate step here, where our entire base is being raised to the exponent 0, which gives us 1 when we evaluate it. So there we go. Those are 0 exponents. Now I'm just going to stop here because getting into negative exponents is kind of like a bigger deal. So I'm going to stop it here. The video is a little bit shorter. We'll pop back in for part 2 and we'll tackle negative exponents and a few examples there. So we'll see you in part 2.